time to introduce Dennis Dello, although I don't think I probably need to introduce him, because I think we all recognise Dennis's face there. And you're the technical lead for Leakage at Acquire now, Dennis, and we all know you, and you've been involved with this network and conference for, I think, well over 20 years before you retired, and it's great to see you still involved with it. Now you're going to set out the sprints findings on micro excavation and leakage location, I believe. So I'll hand over to you, Dennis.
Thanks, Peter. And yes, it's very nice to be still involved with this conference that I started 21 years ago. So yes, in the sprint sessions, we worked on two concepts over what was effectively a couple of days. And I'm going to tell you about one of those, and then Mick will tell you about the other one. So in our sprint, we looked at micro excavation and the concept of carrying out a leak repair within a micro excavation. If we're going to achieve significantly lower levels of leakage in the coming years, we're going to have to find and repair a lot of small leaks. But the problem with small leaks is that the cost of the repair can be a lot more than the value of the water we save. So we're going to have to find ways of making repair of small leaks more economic. So our proposition was to develop a way to repair a leak, leaving the smallest possible footprint, especially for a small leak, at the lowest possible cost and with minimum disruption, using micro excavation techniques and then keyhole leak repairs within the micro excavation. Next slide, please. So we were aiming to reduce costs and increase productivity, also to reduce interruptions to supply by carrying out the repairs more quickly, to reduce the area of work, to minimize disruption to road users, and overall to improve the customer experience. Next slide, please. So overall, the process consists of 4 stages: location, excavation, repair, and reinstatement. And in 2 of those, the areas, the ones in black, excavation and reinstatement, we already have fairly well established tools and techniques for carrying out those. The other 2, location and repair, are the 2 where we do need further research and development. In location, if we're going to carry out the repair within a micro excavation, we clearly have to pinpoint the leak much more accurately than we would normally have to if we were going to have a conventional repair with a conventional excavation. So for micro excavation repairs, we'd need to other methods of repair, of pinpointing the leak very accurately indeed. And then on the repair, we want to be able to do the repair down the hole within the micro excavation, doing all the work from the surface, which is currently not possible. So we need new tools and techniques for doing that. Next slide, please, Andrew. So this is the kind of wonderful artwork you get out of these sprints. This kind of goes through the process that we came up with, starting with the top left-hand corner. Locating the leak, therefore, it has to be a 2-stage process. So firstly, we'll carry out a conventional leak location using a correlator, probably between a couple of hydrants, and get an approximate location for the leak. But then to pinpoint it, we've got several ideas as to how we might be able to do that, and this is one of them. In this case, what we've done is inserted 2 metallic rods vertically from the surface until they're in contact with the pipe, bracketing the leak, so one on each side of the leak. So they might be, say, 5 meters apart. And then we use these as additional acoustic sensing points with a correlator, and hopefully this will allow us to pinpoint the precise location of the leak much more accurately. Then when we've done that, then we'll make the micro excavation using a conventional coring machine, remove the soil using an air lance and a vacuum excavator, and then down in the bottom left-hand corner, we need some way of fixing the repair clamp from the surface, lowering it into the ground, closing it around the pipe and tightening the bolts from the surface, doing all the work from the surface within the micro excavation. We then backfill the hole and then replace the core and reinstate in the normal way. Next slide, please. So here are a few pictures of what some stages of that would look like. This is a conventional coring machine that will do the micro excavation, typically making a cylindrical, probably 300 millimeter diameter hole. Next slide. And then we remove the soil using an air lance and a vacuum excavator in the normal way. Next slide. And then we repair the leak down the hole. And this is the part that needs development. We need to develop some system using long handle tools that will allow us to carry out the repair within the micro excavation, working from the surface. Next slide, please. Then we'll replace the soil in the excavation, compacting it as we go. And then next slide. And lastly, we replace the core and complete the reinstatement in the normal way. Next slide. So a couple of options we consider for the repair itself. Ideally, we would try to develop some system of long-handled tools that would allow us to carry out the repair using a conventional repair clamp, like the one in the picture. That's a typical repair clamp for a small diameter, 100, 150 mil diameter pipe. And we'd have to fix that from the surface and tighten up the bolts from the surface. Now, if we find we can't do that, then we might have to design a modified repair clamp and some special tools designed specifically to work with the modified clamp to do the repair within a micro excavation. Next slide, please. So to look into these areas where we know we need some further research and development, we've got several Acquia projects either about to start or in the pipeline. This first one is one that Jez mentioned very briefly yesterday, transferring minimal excavation methods into the water industry. We know that micro excavation methods are already used by the UK gas industry for certain applications, and also by some water utilities in other countries. But there's very little use of these techniques currently in the UK water industry. So this project will look at methods used in other utilities and in other countries, and identify the issues and the barriers preventing the use of these techniques within the UK water industry. If we find that we need to develop some new tools and techniques, which almost certainly we will have to, then the project will develop a functional specification, which we will then use to facilitate application for innovation funding to develop these. So the project's about to start. We've received a number of expressions of interest, and it should go out to tender in the next few weeks. Next slide, please, Andrew. On the area of precise leak location, we have a couple of PhD projects which are about to start at Southampton University. The first one is the one I mentioned earlier, using insertion rods inserted vertically along the pipe, in contact with the pipe, but obviously being very careful not to puncture the pipe, within a few meters of the leak, and then using those insertion rods as additional access points, additional acoustic sounding points for correlation, which we think should allow for more accurate location of the leak. This project is about to start. It's agreed and will start at Southampton in September of this year. It will actually look at a wider area. We're also looking at it using these insertion rods to give us more frequent acoustic access points on trunk mains and a few other applications, but we will particularly look at it as an application in this case of accurate pinpointing of leak to use with micro excavation. And then another idea is to look at possibly using multi-sensor arrays laid out on the ground surface along the pipe, using various types of sensors like geophones and laser vibrometers to pick up the signals from from the leak, acoustic and vibrational signals from the leak from a number of locations along the line of the pipe. And then we'll need to develop new analysis methods for use with synchronized ground vibration measurements. We're still to agree the start of this project, but again, we hope that we'll have it up and running, ready in time to start at Southampton in September this year. And that's my lot. Thank you.